Alright, as you can see from my amazing virtual classroom, our learning targets are I know about factoring and rational functions, and I can solve rational equations. Alright, so when we're solving rational equations, we want to first identify if there is more than one fraction or item per side of the equation, and then we'll determine the least common denominator and we'll multiply both sides of the equation by it. And then we'll finally always want to check our answer to be sure that it doesn't produce an undefined fraction. And this means having a 0 in the denominator, so we want to avoid that. That's a lot of words. Let's do some examples. So in our examples today, we're going to want to solve for x. So our first example tells us that we have 3 over x minus 1/2 is equal to 12 over x. So since we have two terms on the left side of the equation, we're going to determine their least common denominator and we'll multiply both sides of the equation by it. So recall from class that to find our least common denominator, we'll look at our first term, and our denominator there is x. And we want to look at the second term and make sure we don't have anything left over, but for this one we do. We have 2. So our least common denominator will be 2x. And so now, we're going to take both sides of the equation and multiply by 2x. So we'll take 2x times 3 over x minus 1/2, and then our right side of the equation, 12 over x times 2x. Now, since the left side of our equation has two terms, we'll want to make sure that we distribute 2x to both of them. So we'll multiply 2x to both 3 over x and to 1/2. So we have 2x times 3 over x minus 2x times 1/2 is equal to 2x times 12 over x. And now remember, 2x is technically 2x over 1. And we know that we can multiply fractions by multiplying across the numerator and then multiplying across the denominator. So we have 2x times 3, which would give us 6x, over 1 times x, which is just x, minus, we have 2x times 1, which would just be 2x, and then we have 1 times 2, which would just be 2. And on the right side of the equation, we have 2x times 12, which would give us 24x, over 1 times x, which would just be x. And here's why we multiply both sides of the equation. We're going to be able to do some amazing canceling. We have an x over an x, we have a 2 over a 2, we have another x over an x. Beautiful. So now we don't have any denominators, and we don't have to deal with rational functions anymore, which is great because they're pretty lame. So we have 6 minus x on the left side, and then 24 on the right. And then all we have to do is solve for x. And we can do this in a couple ways. Here's how I'm going to do it. I'll add x to both sides, and then I'll subtract 24 from both sides. So that our x's cancel on the left, and our 24's cancel on the right. And we have 6 minus 24 is equal to x. And 6 minus 24 is going to be negative 18. So we have x is equal to negative 18. And we can't box it yet because remember, we need to check and make sure that this function is not undefined. So if we take negative 18 and we plug it back into our equation, well, we'll have to plug it in for 3 over x, which would be 3 over negative 18. And that's fine. We can have a negative in the denominator. And we'll also plug it in here on the right side. We have 12 over negative 18. And that's fine too. Nothing's undefined. So we are happy campers. Let's do another. So we still want to solve for x, but this time we're given 3x minus 2 over x minus 2 is equal to 6 over x squared minus 4 plus 1. Cool. So this one's a little crazier. That's okay. We like crazy. So remember from class when we were learning about rational functions and adding them together, the first thing we wanted to do was something. Take a second, try to remember what that was. So we wanted to first factor everything. So on the left side, we can't really factor anything, but on the right side, we have x squared minus 4 in our denominator. So we'll factor that. So the left side stays the same, and we'll factor out the x squared minus 4. This is a difference of squares, so we know that this is x minus 2, x plus 2, and we still got our plus 1 hanging out. Alright, so now we need to determine if we have two terms on one side of the equation. Now you may be tempted to say no, because we have a 1 right here, but since this 1 is being added, we actually do have two terms. We have 6 over x minus 2 times x plus 2, and we have 1. So because of that, we'll go ahead and find our least common denominator. So our least common denominator of the side of the equation with more than one term is going to be, so everything from our first term, x minus 2, x plus 2, and then whatever's left over from our second term. Now remember, 1 is technically 1 over 1, so we could write times 1 if we wanted, but it doesn't make a difference, so I'm not going to. And now, all we have to do is multiply by our LCD on both sides of the equation. So we'll multiply the left by x minus 2, x plus 2, and we'll multiply everything on the right by x minus 2, x plus 2. And just like in the last problem, remember we need to distribute this x minus 2, x plus 2 to both terms. So both the 6 over x minus 2, x plus 2, and to the 1. Don't forget about that one. He is important. So on the left, we have x minus 2, x plus 2 times 3x minus 2 all over x minus 2. So I just wrote everything in the numerator that's being multiplied. And then on the right, probably going to run out of room here. On the right, we'll distribute the x minus 2, x plus 2 to our first term. So we have 6 times x minus 2, x plus 2, all over x minus 2, x plus 2, and then 1 times anything is just itself. So x minus 2, x plus 2. And now we get to do everybody's favorite part of math. We get to cancel some stuff. So we have x minus 2 right here. On the right side of the equation, we have an x minus 2, and an x plus 2, x plus 2. How amazing. We love canceling. So on the left side, we're left with x plus 2 times 3x minus 2 is equal to 6 plus x minus 2, x plus 2. And now on the left side of the equation, we have two binomials being multiplied, and we also have that on the right side of the equation. So that's kind of screaming at me that we need to FOIL. So I'm going to go ahead and do that. So I'm going to FOIL the left side. So we have first 3x squared outside minus 2x inside plus 6x, and last minus 4 is equal to 6 plus. Now I could take the time and FOIL this out, but at the beginning remember that we factored this x squared minus 4 to get that x minus 2 times x plus 2. So I know that if I were to FOIL this out, it would be x squared minus 4. So I'm not going to take the time to do that, but you can if your heart desires. Plus x squared minus 4. So now we just have some like terms, so I'm going to simplify this a little bit. I'm going to add these middle terms, and on the right I'm going to add the 6 and the negative 4. So on the left we get 3x squared plus 4x minus 4 is x squared plus 2. And so now we have a quadratic on the left, a quadratic on the right. So I'm going to move everything to the left and make it just one quadratic. So I'll subtract x squared and 2. And we get 2x squared plus 4x minus 6 is 0. And now I could do some AC method with this guy or use the quadratic formula, but one thing I noticed is that each of these three terms have something in common. They each have a 2 in them, so I'm going to factor out a 2. So we have 2 times x squared plus 2x minus 3 is 0. And the reason I do that is now I can divide by 2 and just get rid of it. So we have x squared plus 2x minus 3 is equal to 0 divided by 2, which would just be 0. And now I can just factor the left side of this equation. We need something that multiplies at negative 3 and adds to 2. Think about that for a second. But it's going to be this. X plus 3 times x minus 1 is equal to 0. And now we have two terms being multiplied. So now we can just split this into two separate equations. We have x plus 3 is 0 and x minus 1 is 0. And solve for x, we get negative 3 and 1. But we're not done. Remember, we have to go back and check to make sure that these are not undefined. So if we go back to the very beginning, way up here, and we plug in negative 3, we really only care about the denominators of these, because remember, the only time this can be undefined is if our denominators are undefined. So if we plug in negative 3 here, we get negative 3 minus 2, which would be negative 5 in our denominator. That's fine. And here, if we plug in negative 3, we'll have negative 3 squared, which would be positive 9, minus 4 would be 5. So that's fine too. So we know that one's good.
Oh, yeah.
And then we'll also plug in our x equals 1. So if we plug in 1 here, we'd have 1 minus 2, which would be negative 1. That's fine. We can have negative 1 in the denominator. If we plug in 1 here, we'll have 1 squared minus 4, which would be negative 3. And that's fine. We can have that in the denominator as well. So boom, they both worked out.